Hi, everybody. This is the intro slash review, I guess, depending on when you're watching it, on the total atoms worksheet. So basically what this is going to be is just making sure that if you look at chemical formula, that you got an idea of what elements are there, how many of each, and you can calculate those out. And this is really important for an awful lot of things as we move through really Chem A and Chem B, whether we're trying to, balance equations or we're trying to calculate molar mass or whatever the case may be. You have to know what you're working with. And this is one of the ways that we do that. So there's a couple terms that I hope you're familiar with now. If not, you might want to go back and review some of the lectures from either your notes from class or posted on my site. But that's subscript and coefficient. So rather than trying to memorize some words, it's nice to just listen to what they tell us. And if we break this guy up into its prefix and its root, we got sub, which, think about like if I said, hey, it's going to be sub-zero temperatures, that means below. And then script, like if I gave you a script, that'd be something that's got writing on it, like from drama class or whatever. So that would mean that this is writing below. So I'm going to put writing below, and then I'm going to put in parentheses here, only element it follows. And what I mean by that is the subscript only is referencing the element that it follows. So here we got coefficient. And I'm not telling you that this is the greatest definition in the world for coefficient, but this will get you through what we need to in chem. So for coefficient, I'm going to put big number in front. And then in parentheses here, I'm going to put apply to all. So that means that if you see a coefficient, it's got to be kind of carried through for everything. So I did an example here for you, and I'll do another one as well, but we've got H2O. Hope you're familiar with that. So this 2 here is a subscript. Gosh, where's the coefficient? Well, there's not always one there. If there was a coefficient, it would be in the front right here, though. So we don't see one. That's implied that it's 1, that, this H2O exists. This 2 only applies to the H. So first column here, I wanted you to think about the elements that are present. And remember that if we go back to the old periodic table, if you've got an element that has 2 letters in its symbol, that second letter is always going to be lowercase. So if you see formulas with stuff kind of squished together and there's just a mesh of letters, look for the uppercase, lowercase break. That'll show you visually where the individual elements are. So we're making our way through this, right? We've got hydrogen and oxygen. This only applies to hydrogen. So there's 2 hydrogen. I get that there's no 1 in subscript here. You wouldn't say like H2O1. It's a little redundant. So they just rated out H2O. So you got 1 oxygen. Check. 2 of these guys, hydrogen. 1 of these guys, oxygen. There's 3 total atoms there. So if we jump down to this, here's an example where you've got a coefficient and a subscript. So I would say, all right, I know I got hydrogen and oxygen in this. This is how I do it. I usually cover up the coefficient and then I look at the subscript, figure out how much of each element and then multiply it by the coefficient. If you find you're comfortable with another way, that's fine. But I would kind of figure this like this. Okay, I got 2 hydrogen times 2 of them. So that's 4. Another thing, I get with this example, 2 plus 2 is 4 and 2 times 2 is 4. Sometimes kids will want to add the coefficient, the subscript. Don't do that. You need to multiply it. So for here, remember, it's not written as O1. I got the O, so there's 1 oxygen there. I wouldn't say 1 plus 2 is 3. I'd say 1 times 2 is 2. So I got oxygen equals 2. So for this here, I've got 6 total atoms. And if you think about it, it kind of makes sense because I doubled up H2O. I had 2 of them. I had 3 with H2O. And if I double that up, I should have 6. So Sometimes you might find that things are locked in parentheses. And if you see something that's in parentheses, that means you're just treating that whole thing as one. So this sulfate or this SO4, it's locked in parentheses, and then there's 3 of everything there. And then sometimes you can find stuff where you've got something locked in parentheses, there's subscripts and there's coefficients. Don't get overwhelmed by looking at the whole thing. I would just try to do this column by column, step by step, and then just kind of break it up and work from there. So if I jump down to this guy, we've got a little bit of everything, right? This is how I would think it through. It looks overwhelming there, but let's just chunk it. Got some boron, got some nitrogen, and I've got some oxygen. So notice here too that this NO, that has to be 2 different elements, right? I mean, if I'm scrolling around for NO on here, I'm gonna be out of luck. But that's capital, so that's 2 different elements. So then I figure out how much of each one. I gotta figure out how much boron, I gotta figure out how much nitrogen, and I gotta figure out how much oxygen. So I do it like this. I cover up the coefficient, and then I'd say, okay, well, here's the B, there's a boron, okay, there's no subscript behind it. This subscript only applies to what's locked in parentheses because that's directly what it follows. We're treating that as 1. So 1 times 2, 2. Cover this guy up. Okay, so I got NO3, but I've got 3 of those. So really, I mean, if we just took a look at just this NO3, 3, say you had, there's NO3. Well, I've got this 3 in subscript, so it's really saying I got 3 of those. So I don't know if it's going to be real time efficient for you to sketch all these guys out, but you know, this is basically a visualization of what that would be. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 times 3. So that's not where I'd want to go. 3 plus 3 is 6, because again, we've got 3 NO3s there. So with all that being said, we still have a coefficient to deal with as well. So this is how I do it. Okay, this 3 with that n is 3 times 2 is 6. Go back to here. Okay, I got 3 O3s, so I got 9 oxygens times 2 is 18. And then if my mathematics work out correct here, if we've got 2 and 6 and 18, that should be a grand total of 26 atoms. So you need to know how to do this before we move any further. If you got questions, shoot me an email, or if you know, we're in session, come ask a question during class or before or after school. That's all I got for you. Bye-bye.